In the previous video, we had learned or discussed about the modern periodic law, and in brief, we saw the modern periodic table. In this video, we are going to be talking about the nomenclature of elements whose atomic number is greater than 100. So initially, when elements were being discovered, it was said that when they had started, like in mid of 1850s, or yeah, 1850s to up to 1950s or 1960s, close to that, they said it was said that at least one element was discovered each year. So the naming of elements was given the credit. I mean, the naming of elements was done by the discoverer or the discoverers. But recent times, as as we go into more heavier elements, these are generally artificially synthesized in the lab. And due to this, there are various disputes regarding their name that started coming up. For example, element 104. Americans named it Rutherfordium, whereas Soviets named it Kirchhovium. But so to avoid such issues, IUPAC gave a nomenclature for new elements till they're officially recognized. And generally, the symbol has three letters, and they are again derived based on the rules put forward by the IUPAC. The reason this is done is because only after it is officially recognized, an element is given its name. For example, organazon, that is one of the four elements that was recently added to the periodic table, was first observed in the year 2002. And after a lot of time, it was officially recognized in the year 2016 for its existence. So, I mean, so even if there was another scientist who managed to replicate these results, it would have the name is given only after proper recognition by various bodies like the IUPAC. So if you notice, okay, so 1, 2, 3, and 4, these four elements were recently added to the periodic table. And they were given its IUPAC name before that. Okay, so before 2000, assuming, if you look at the periodic table which was present before 2000, you would have seen all of these elements and these as well would have been just the IUPAC symbols. So one of the examples is this. Here, if you see 110, 11, 12, 13, 14, all these elements were not yet discovered and they were given the IUPAC names. So the IUPAC nomenclature is quite simple. Okay, first of all, what we need to do is the name is derived from the numerical root of each of these letters. So, for example, for 101, one is un, so un, and 0 is nil, which is nil. Again, 1 is un. So till here, it's just the word roots of each of these numbers. They are then placed in the order of their appearance, and the letters em is added in the end. So basically, we're just joining these words together to get us the IUPAC name. The next one is that the names are shortened in certain cases. Suppose if ENN, that is 9, and 0. So if it's 90, instead of having three N's, it can just written as ENNIL. So one of the N's is removed. And again, here if you notice, here you have 102. And 2 is by, and in the end we need to add em. So instead of writing two i's, we just remove one of the i's and just write one of them. The symbol is then obtained after taking the word roots of all of these. So if you see here, the one in red is the first letter of each of these word roots, and that in turn forms the symbol. So if you notice, you have three letters to the elements which have not been officially given names for. So here, if you see, I've also written the the name of the element as well as its IUPAC symbol after its discovery. And so the next element after organazon will be added under the first group, that is the alkali metals, and that will have the atomic number 119. So they say that you'll have 119, 120. Again, you might have set of another set underneath the lanthanoids and actinoids. But as we go forward, as the elements start becoming heavy, they start becoming highly unstable in nature. And that is exactly why it takes this long for heavy elements to be synthesized. Especially after curium, whose atomic number is 96, the stability of the atoms decreases by a great amount. And in turn, it becomes very difficult for the synthesis of these elements in the lab. So with that, I think we're done with the nomenclature of the elements, with atomic number more than 100 given by IUPAC. So basically, you just have the word root for each of the digits, and they're just joined together in the order of their appearance, and in the end the letters em is added, uh, and the symbol is basically the first letter of each of these word roots. We also learned about why it was necessary to have nomenclature. This just regulated, or rather ensured, that there was a particular way of knowing if a particular element should be added to the periodic table. Um, Not only that, it led to less conflict, and there was a more unanimous decision on the matter of the names of the elements in the periodic table. In the next video, we will be discussing about the electronic configuration of elements and the periodic table. So do check it out.